Hello, we're going to start in a couple minutes. I'm going to go over part of the test today, at least the questions that people seem to be missing. And the reason they're missing things is kind of reading related more than math related, but we're going to do that. And then after that, I am going to use the rest of the time to start percents. Percents and percentages are kind of the same thing. I'm not sure the difference in that question. But percents are also the same thing as ratios, so it's not too bad. So if you're good at ratios, you'll be good at percents. Hi, Lyra. Hi, Porter. But yeah, I'd like to go over a few of the test questions that I'm getting some confusion on, then give you another shot at those. And then from there, I'll start percents. So we're not going to spend every time on the test. I wasn't sure how well people would do. I use book questions. I normally make my own questions up. I don't like book questions all the time because their wording is weird. Yeah, you're going to take notes on percents today for at least part of it. Percents are not hard. I mean, if you understood ratios, you'll get percents. It's the same thing. It's just percents are a bit more specific type of ratios. But we're going to start with going over two questions from the test that give people a lot of confusion. And if you turned your test in, I marked it up. Feel free to correct answers and then return it back to me. And I threw in the percent PowerPoint. It's the one I use for 7th grade, so we might not go over all of it, but it's in there. That's up to you, or you could just print out the slideshow. I mean, it's all there. Eventually, yeah, you need to know all of it. It's not difficult stuff. It's nothing you can't handle. It's just, if I'm following what's in your book, then it doesn't get to all of it. It does things a little different. Your book likes to use like pictures and stuff. I'm not the biggest fan of pictures. I'm not going to have you draw like, here's 100 grid, shade in so many to represent a percent. Yeah, I'm just going to say, hey, it's part of 100. But anyways, I'm going to start by just explaining a couple of the problems. I'm not going to give you answers to these on the test because I would like you to go back and double check things. And then we're going to get into percents. Yeah, Logan, it's actually on the board. It's been there since the beginning. I'm not going to give you the answer to it, but I will walk you through some reasoning behind things. And I would like you to double check if you missed it, go and correct it, and then resubmit your test. And I'm going to do this one for one other problem on there too that a lot of people have been missing, just from what I saw this morning when people turned things in. If you did not turn your test in yet, I'm still waiting for you. Please get it in. If you turned your test in kind of like late morning till now, I haven't looked at much of them yet. So I'm still getting to some of them. So let's look at number one. Number one says it takes Hunter 90 minutes to drive 97.5 miles. And it wants to know how many miles per hour does Hunter travel. The first thing you need to realize is it's asking for miles per hour, and it gives you miles in minutes. So this minutes, right, 90 minutes, you need to tell me how many hours that is. You probably know that off the top of your head, but you need to figure that out. Keeping in mind there's 60 minutes in an hour, So that's going to give you one set of 60 and then a set of 30, so that's 1.5 hours. So you should be using 1.5 hours to solve this problem as opposed to the 90 minutes. And then you just set up your unit rate and find your unit rate. So again, it's asking for miles per hour. So you're going to choose the way to set that up so that makes sense. Again, miles on top, hours on the bottom. So 97.5 over 1.5 will give you your answer. And then don't forget your units being in miles per hour. Right, so that's how you're going to do number one. A lot of people overlook the turning the minutes to hours thing. So if you're getting an answer that's like 1.05, something like that, I don't remember what it comes out to be. 97.5 divided by 90, 1.08, 3 repeating. This is because you need to change minutes to hours. And then do it. What if we don't have our notebook? I gave you the slides in the classroom. You can just look on this. You can print those out. You can write in those. You can start a new notebook. You can find some way to do it. But I'm going to try my best to give you slides on everything we're covering. That way you just have another thing for it. We're going to start by going over the test, then we're going to get into percents, Sarah. So I am going to start percents today. Nothing too major. You're not going to have an assignment on it, but we are going to discuss percents. I don't want that. I want this problem. I deleted the problem I wanted. Close that. Look at this. Right in that. This was the next one that people were having trouble with, and I don't remember the number off the top of my head, what number this was, but honestly, most people miss this. In fact, I think the only one that got this one right was Eli, and that was after he actually emailed me with questions about it. So I do want to go over this one. And you do have the ability to go back, unsubmit your test, redo this problem, and then send it back to me. I just don't know what number it is. Let me look what number it is. This is number 6. So again, if you got your test back and this was marked wrong, it was slotted for 3 points, and that was me being generous with it. I could have put more points to this, but I gave it 3 points. So if you missed this, I took 3 points from you. And again, that was being generous. So go back and fix this if you missed it. And then turn it back in, because most of us did, which means I probably didn't do the greatest job showing you how to do this. And the biggest thing that came in play was the shipping. Most people just kind of ignored the shipping. And honestly, most people who did ignore the shipping got this right if there was no shipping. So let's talk about how this relates to shipping. So first off, we got a website. Website A offers, yeah, I'm getting to them. No, I'm getting to them today, Logan. Website A offers 5 reams of paper for $22.99, plus it has shipping of $5.95. I'm gonna do website A in blue. Okay, so let's do all the work for this. We want to find out the unit rate for this, right? We want unit rate so we can compare which price is better and round it to the nearest cent, which, you know, is kind of not that important. But so we're looking at website A here, and we want the unit price for this. So here's your ratio, 5 reams for $22.99. So you're doing $22.99 divided by 5. And if you stopped there, you would be getting your unit price. And this is reams. Right, so how much does 1 ream cost? So here, when you do that, $22.99 gives you $4.60 really, because it wants you to round. And 60 cents, which is where a lot of you stopped. So a lot of you have that as an answer there, but you didn't take into account shipping. And shipping is a one-time offer. It's you pay this once and you get however many you ordered. So that's going to just be tacked on to that. So we're going to add the $5.95 to that. So $4.60 plus $5.95 should be coming up to a total of $10.55. So really, if you're ordering from website A, one ream of paper is going to cost $4.60, plus they're going to charge you $5.95 for shipping. So your total cost of one ream of paper is going to be $10.55. And again, a lot of people just kind of forgot to add on the shipping to that. Website B, we're going to do in red. Your ratio is here. It's done the same kind of way. You have $36.99 over 8 reams. So here, even though it costs more, you're getting more reams with this. We want to know the unit price. So the unit price of that is, again, you just divide it out. So 36.99 divided by 8 is going to give you about, and we're going to round this to the nearest cent too, so this is going to be $4.62. Now right off the bat, you should note that this one here is a better buy if you're just comparing paper. This is $4.60. This is $4.62. However, that also has shipping to it, so you're going to have to add the shipping to it. So you're going to get plus the $9.95, and right away you know the shipping is way more for this one here, so you know this one here is going to be more expensive just because of that. But how much is this one actually going to cost you per ream? You got to add those up. So 462 plus 995 is going to give you 1457. So these here are your true unit prices because you have to pay for that shipping. A lot of you kind of left out the shipping part, right? So then it's asking you to tell me which website offers the better buy per ream. So your answer for this part should be website A. And it's going to be for $10.55. That's its unit rate. And then by how much? To get the how much, you just want the difference. And a lot of you did that with just the cents. You subtracted the 2 cents and got, oh, well, hey, there's 2 cent difference. I can't write very well. How much different? To solve that, you're going to take your 1457 and you're going to subtract it from your 1055, and you're going to get 204. So it is a $4.02 difference. I don't know if my head's in the way. No. Okay. So it is a $4.02 difference. And that's what it's asking you to do. And again, a lot of you did it great if it didn't have the shipping. You just had to add the shipping onto it all. And shipping, again, is just a one-time thing. On number 8, I did do the graph, but didn't know how to put it on the page. I don't think it asked for a graph. I think it asked for a table. Let me look at that. Yeah, it said to make a table, Charlie. So if you want to look at number 8, in fact, some of you could probably learn how to make a table in Google Docs. It would be nice. But anyways, it's asking you for a table, not a graph. You can go to Insert, Table. So under, well, I should write it this way. At the top of your Google Docs, there's an insert button. Underneath insert, there's a table option. Insert the table. A lot of you did it weirdly. I didn't take off points if you made a horrible table, but you should learn how to make a table. Let's see, here's our blank copy of the test. But if I go over here to insert, I can go to table, and then you can actually draw out your table this way. If you want to make it lengthwise, boom, puts it in that way. And you can do like hay, and then you can do horses, things like that. That's my master, so I'm not messing with it. Yeah, Charlie, if you want to go and unsubmit it and then turn it back in, I'm not sure what yours looks like. I can bring it up real quick here. Yeah, I took off because you didn't have a table, so take it back, put the table in and resubmit it, and I'll look at it again. This is a learning experience for all of us. But anyways, for number 8, the other thing that I saw a lot of people not doing is when you make a table, they have labels. I got to know what you're talking about. You can't just throw numbers in here. You can't just be like 1, 2, 4, 8, 6, 3, whatever it is. That doesn't make sense. 3, 6, right? I need to know what these numbers are. Should we send the test today? Yeah, you can fix it. I'm probably not going to get a chance to look at it until Monday. I got to get your science posted. I got a couple more videos I need to record for you, and then your assignment sheet and stuff. So I'm going to spend the weekend doing your science, but your science chapter 6 will be open on Monday. So keep that in mind. But yeah, when you make a table, label things. I had a lot of people who made their table vertically, which is fine, but they didn't tell me what things were. I need to know which column represents horses, and I need to know which column represents bales of hay. So you got to label things. Oh yeah, I'll do decimals. I'm sorry, not decimals, percents. I'm going to start percents now, actually. So let's look at percents. Your next chapter is going to be on percents. So off to the side, fixed test, and then science chapter 5 should be done. I'm not going to get to grading everything this weekend, but chapter 6 will be chapter 6 starts Monday, and give yourself like 3 weeks. So calendar wise, 1, 2, yeah, you got Easter in there too. Let's say try by the 1st. Try to get this due by May 1st. But I'll put drop boxes in and stuff next week. You'll have a week for videos, stuff like that, and like a week for section assessments and key term things, and then a week for your projects. You have 3 questions left on test. We'll do the 3 questions, Logan. It's a test. Unless you don't understand what one's asking, then you can write there. But for math, your next chapter is on percents. And percents you see all the time. Percents are pretty common. Please follow along with the PowerPoint. if you have it. Logan, if you're having trouble with those 3 questions, shoot me an email with the 3 of them on. Oh, for science? Yeah, then finish it. Whenever you get it in, get it in. Again, I'm probably not going to get those grades in until after Monday anyways, but I'm going to try my best. All right. It's 3 questions, Logan. They're multiple choice. Can't you just like go through number 7? All right, let's do 7 on the test before we start percents. So this is for Sarah. You have a photo? Right? It is 8 inches long. Boom. I guess inches. And 6 inches wide. He wants to make a new photo. That's resized the same. I guess that's too far over. A new photo that's larger, where it is 24 inches wide, and it wants to know that length. Again, you could think of similar figures like we did the other day, just corresponding sides line up, but it is just a ratio problem. So you have tops. I have 8 and x, so let's leave those on top. And I have sides. Solve for x. Is that enough, Sarah? Let me get to the notes, Eli. Let me at least start explaining them first. So percents. Percents are pretty simple. Percents are ratios. That's all it is. It's a ratio. Everything you know about ratios is now true with percents. However, it's a ratio with a denominator of 100. So percents are fractions because ratios are fractions. Right, with a denominator of 100. See the common theme of 100? Percents are also parts of 100. It's all about 100. 100 is part of the definition of percent. Anytime you're dealing with a percent, you're dealing with the number 100 in some way. For example, 5% is equal to 5 parts out of 100. Or it's a ratio, 5 to 100, 5 to 100, where your denominator is 100. Of course, 5/100ths can be reduced, so keep that in mind. I can reduce this. I can divide that by 5 and divide that by 5 and get 1/20th. So this also equals 5%. So keep in mind you have fractions that you can deal with. Another example, 125%. Again, it's still parts of 100. So that's 125 over 100. It's always with a denominator of 100. This can also be reduced. I can divide each of these by 25. And this becomes, what is that? 5/4, which is also equal to, if you like mixed numbers, 1 1/4%, right? Oh, I'm sorry, not percent, just 1 1/4. They are all the same thing. So bottom line being, what is it? Isn't 100% mathematically impossible? No, it's not. You can have 125% of something. If I have, I don't know, if I have an apple that I bought for $1 because it was a mad expensive apple, and I sold it to you for $1.25. You paid 125% of the apple. So you can have 125%. Just like you can have improper fractions. They're the same thing, right? 125 over 100 is an improper fraction. You can have 5/4 of something. You can have 1 1/4 of something. It's possible. It depends on context, but yeah, you can. There are cases where it doesn't make sense to go over 100%. Right, 100% of the kids in the class is all of them, so you can't have more than 100% in that sense because you can't have more than all of your kids in your class. However, comparing two classes or something, some classes can have more kids than others, and therefore they have more than 100% of that other class. I mean, it depends on context, but yeah, it's possible. It's possible to have decimals as percents. This is possible to be a percent. That's just 0.5 over 100, which again, this is frowned upon because you have a decimal inside of a fraction. So get it out of there, move that, move that. So you get 5 over 1,000. Doesn't mean it's not possible. It happens. It shows up places. But percents are parts of 100. That's really all you got to keep in mind is that 100. Percents are parts of 100. Percents are also just different ways of writing fractions, ratios, decimals, yeah, I think those are the three that you know right now. So they are just different ways of writing fractions and decimals. So in other words, a percent is the same thing as a fraction, is the same thing as a decimal. It just looks different. And by definition, it deals with the number 100. So any fraction that deals with the number 100 is going to probably be a percent. Any decimal that deals with the number 100 is probably going to be easy to make a percent, and so on. Your job is to be able to go between them, and you'll have practice on it later. I'm not going to give you practice over the weekend. You need to spend quality time with your family because you're probably not sick of them yet, hopefully. I don't know. But anyways, you're going to have to know how to go from writing a percent to each of these. So let's look at our first case where we go from a percent into a decimal. Okay, so here I'm not concerned about a fraction, I'm talking about a percent equaling a decimal. How do I write a percent as a decimal? So if I give you the percent, for example 16, what is that as a decimal? Well, there's a couple different ways to look at that. Probably the way that makes the most sense right now is to actually write it as a fraction first. So what we're going to do is we're going to take this to a fraction. And again, just using the definition of what a percent is part of 100. So 16% is 16 parts of 100. And then once you have it as a fraction, it's really easy to make a decimal. You just read that. That's 16 hundredths. So that's 0.16. The other way to look at it is to take 16% and just divide it by 100, which is going to look very similar to this, but I'm going to write it this way. Divided by 100. So 16 divided by 100 equals 16 hundredths. It's just a division problem. I mean, it's a fraction, it's a ratio, it's division. So 16% is 16 out of 100. Just divide it by 100 and you get your decimal. Now the great thing about 100 though is it makes the division really easy because fraction or percents will always be 100. So you're always going to be ending up dividing it by 100. If you have a percent such as 62.5%, well, when you divide by 100, right, divide this by 100, whenever you're doing that, the only thing you actually do is move this decimal point over once and twice and put your decimal point there. So this is going to equal 0.625. You just move the decimal point. So 120%, move your decimal twice, once, twice, that equals 1.2. 54%, once, twice, equals 0.54. 672.35%, same deal. Move that decimal point once, twice, you get 6.7235. All what you're doing is moving the decimal point twice. In the way that I remember it, because you want to remember what direction to move the decimal point, you'll note if you're going from a percent, you're always moving it to the left. So a percent to a decimal, move it to the left. From a decimal to a percent, if I'm going in reverse, then you're going to move it the other way. But the way that I remember it is if you're going away from a percent, like I'm given a percent and I want to get away from that, I want to get away from the percent and go towards a decimal, I'm going to move it away from the percent sign. If I'm given a decimal and I want to take it to a percent, so if I want to make this a percent, I move it toward where the percent sign would be. And that's how I go. Remember which direction I'm moving it, at least. That's how I do it. I remember, am I going away from a percent? Am I starting a percent and leaving it? Or am I starting at a decimal and going towards the percent? So a little mnemonic there, if that makes sense, to keep your direction straight. So again, if you wanted to go back to a percent, you'd move this once, twice, decimal goes there, you need the placeholder 0. That would equal 120%. And again, that's what you started with. Here, once, twice, 54%. Once, twice, 762.35%. It just tells you which direction you're moving the percent in. Any questions on percents and decimals? Pretty easy to go between. It's going to be like second nature to a lot of you by the end of this. It's just going to be like, oh, here's a percent. What's this as a decimal? Move it. When it gets to calculations and stuff, we don't really use percents. We make them decimals or we make them fractions, and we deal with it that way. So we really percents are kind of frowned upon in a lot of things. We try to get rid of them. Let's see. Let's look at going from a percent to a fraction, which we did a little bit of earlier. It's really not much different. Let's just get a new one. So let's look at percents to fractions, because again, percents and fractions and decimals are all the same numbers, they just are in different forms. So if I want to go from a percent to a fraction, I'm just going to remember my definition of percent, right? So I'm going to write it with a denominator of 100. So in that case, I don't know, let's do, I don't know, 50%. You all know is 1/2, hopefully, right? If I want to make it as a fraction, again, percents are part of 100, I just put that over 100. And now it's a fraction, and then I reduce. So don't forget to reduce these things. And that's probably where the hardest part comes, right? I can divide that by 50, and I can divide that by 50, and I get 1/2. So 50% is the same thing as 1/2, right? So 66.6 repeating percent, write it as a fraction. That's 66.6 over 100. Now again, you don't like the decimal in there, so I'm going to multiply it by 10 to move it out. Right? 10 is going to make that jump once, just like when you multiplied by 100 it jumped twice, or divided by 100 it jumped twice in that direction. Right? Multiplying by 10 is going to make it jump once, and that's going to equal 66.6 over, and again this one's going to jump once too, over 1,000. And then you can reduce that, which is going to be, I don't know, they're both divisible by 2 off the top of my head there. Which, yeah, I don't know why I'm using a calculator. It's 333 over, and then half of that is going to be 500. So that can't do it. Yep, just plop the percentage on top of 100. That's all there is to it, and then you just kind of reduce it. So if you have, I don't know, what the notes went backwards on this one, 31.5%, 31.25, plop it over 100. Again, you don't like the decimal point there, so move it out. That's twice, so move this one twice. One more, and then reduce. But yeah, that's really all there is to it, is putting it over 100. Going from a fraction to a percent is a different story here. So for the last 5 minutes, we'll go over that, which should be pretty easy for most of you. I won't do that. Remember, percents and fraction are the same thing. What if I go from a fraction to a percent? I'm going from a fraction to a percent. What about something like 17? Just the number 17? I don't remember what you're talking about. Are you talking about 17% would equal 17 over 100? That doesn't reduce. That's that. If you want to go from a fraction to a percent, given a fraction, I don't know, 4/5 is a nice fraction. What you're going to do is you just want to make this so it has a denominator of 100, and then just write the numerator. And then you should realize, hey, this here is a proportion. I can cross multiply to solve this if I really wanted to. That's one reason, one way to do that. So the other way to do it is to just think, hey, what times 5 gives you 100, 20, 40 times 20 gives you 80, so this is 80%. So 4/5 equals 80% because this will equal 80. Again, you could have done your cross products where you get 5x equals 400, divide that by 5, divide that by 5, x equals 80. Either way, you get the same answer. It is a proportion in that sense. You can do that. And yeah, you can do that if your denominator is even 17. It's just going to be an ugly number. So I don't know, maybe you have 9/17. You want it to be a percent, you need the percent over 100. So whatever the percent is going to be here, you can do 9 times 100 gives you 900, and 17 times your x gives you 17x. Divide by 17, divide by 17. 900 divided by 17 gives you an ugly number. This cancels, leaves you x equals 52.941. And there's some other stuff to it. So this would be 52.941%. Not too difficult, just set it up as a proportion and solve. But remember, your fraction is always going to want to have a denominator of 100 when it comes to percents. You'll get some practice on percents and stuff next week. Next week is a pretty short week. I believe you have school Monday, you have school Tuesday, and you have school Wednesday. Thursday is Holy Thursday, Friday is Good Friday, Saturday, Sunday, and Monday you have off as well. So that Easter Monday is now off, even though that was taken away for a snow day. Earlier in the year, they're giving it back to you for some reason now. I don't know, I don't make the schedule, but we'll get some practice on percents next week, just going from changing the different forms right now, getting you used to that, and then take it from there, I guess. So there is no work over the weekend unless you're behind on science. Make sure you get your projects into me. There's a Dropbox. Make sure you get your test into me, which can be taken online, and make sure you get your key term quiz into me, which I think you can just edit there and resubmit. And with that, we're done. Have a good weekend. If you have any further questions, send me an email. I'll try my best to get back to you. So thanks for tuning in. Bye.